Right. This is Algebra 2, OAS, A2, A13. The student will solve absolute value equations. Absolute value equations often have two solutions. It's something we have to keep in mind. And the key word when we're solving these things is isolate. I'm going to work through a few examples. Hopefully by the time I get through with the last example, the techniques for solving absolute value equations will be clear. Here we go. The first simplest type of absolute value equation is the absolute value of x is equal to some constant. Okay, so if I were going to solve this, I'd ask myself, well, what value could I put in here that would make this true? I could put in a 3. The absolute value of 3 is 3. Or I could put in negative 3. The absolute value of negative 3 is also 3. So I'm taking the absolute value and I'm getting 3. That means x could be 3 or x could be negative 3. Notice when I take the absolute value of a negative, I still get a positive value. The absolute value of negative 3 is positive. You'll never take the absolute value of something and get a negative value. It'll always be non-negative. It'll be 0 or greater. So this is the type of thinking we're going to use whenever we're solving absolute value equations. We'll just write two equations. This is equal to this, or this is equal to the opposite of this. And then we'll solve if necessary. In this case, it's already solved. Oftentimes, when you're taking these standardized quizzes and tests, you'll see the answers written like this. Negative 3, 3. Doesn't matter which one comes first, you can put the 3 first. Or you might see them written like this, the set whose members are plus or minus 3. I think on today's worksheet, the answers are going to look like this. But any one of these is an appropriate way of responding to this, finding the solution to the absolute value of x is equal to 3. Here we go. I'm going to use this kind of thinking right here. Solve. Always isolate the absolute value expression, then write two equations. This is all by itself on the left side of the equation. It's already isolated. This absolute value symbol is already all by itself. There's nothing multiplied by it, nothing added to it, so it's already isolated. Then I write two equations and solve them. So I can say, I don't have to make this positive. This is a variable expression. So I'm not going to take the absolute value of this. I'm going to write two equations, ignoring the absolute value symbols. I'm getting rid of them and saying, either this is true, 8k, negative 8k is equal to 64, or if this turns into negative 64, the absolute value of negative 64 would also be 64. So negative 8k could be negative 64. I solve these two, and those will be my two solutions for this absolute value equation. Remember, absolute value equations often have two solutions. So we set up two equations. And that's what I'm doing right here. Here we go. I said negative 8k is 64, or if I plug in a negative 64 in here, the absolute value of negative 64 is also 64, so negative 8k could be negative 64. And then I solve both of them. Dividing both sides by negative 8, k could equal negative 8. These cancel. 64 divided by negative 8 is negative 8. Or, dividing both sides by negative 8, these cancel, gives me positive k is equal to positive 8. So there are two values I could put in here, and you can try that if you want. I'll leave that to you to prove to yourself that both of these will make this equation true. Because once you plug them in and then take the absolute value, you plug a numerical value in there, then take the absolute value, you will get 64. On today's worksheet, the answer will probably look like this among the multiple choice selections that you'll have. This would also be an appropriate way of writing the answer. They won't always be direct opposites of each other. In this case, they were. Let's take a look at the next one. Solve. Always isolate the absolute value expression, then write two equations and solve. So I look at this absolute value expression doesn't have anything added to it out here or anything multiplied by it, so it's already isolated. Now I can write my two equations and solve. The first equation looks just like this without absolute value symbols. 8 plus 7n could be equal to 48, because if I take the absolute value of 48, I get 48. Or 8 plus 7n could be equal to negative 48, because if this turns into negative 48 and I take the absolute value of it, it'll be positive 48. Here are my two situations. I'm going to solve them both, and I'll hopefully know the solution to that absolute value equation. Here I go. I'm going to subtract 8 both sides and then divide 7 both sides. Here we go. Negative 8. I'm setting 7n is equal to 40. Dividing both sides by 7, excuse me, n is equal to 40 over 7. I would just leave it like that. Leave it in an improper fraction. If you could reduce it, reduce it. But leave it in improper fraction. It's the easiest, quickest way to arrive at your answer. And that's how you'll often see it on the ACT and in college and on this standardized worksheet that you're doing. Leave the answer just like that. You don't have to give me a decimal. Just leave it just like that. Here I'm going to subtract 8 from both sides. The other equation, 7n is equal to, what is that, negative 56. Divide both sides by 7. These cancel. N is equal to negative 8. So I've got two solutions here. And I write them like this. 40 over 7. Comma, negative 8 is probably how you'll see them in your multiple choice problems today, multiple choice answers. Okay. Example number 3, solve. Always isolate the absolute value expression, then write two equations and solve. So that's what I'm going to do this time. I look at this one. Unlike the other two, I've got something added to this absolute value and something multiplied. So I'm going to subtract 7 from both sides, then divide both sides by 2, then my absolute value symbol is isolated, at which time I write two equations. You have to always isolate the absolute value expression, then write two equations. So that's what I'm going to do. Here I go. I'm going to subtract 7 from both sides. Rewriting yields 2 times the absolute value of 2x is equal to 12. I still am isolating this absolute value. I don't want that multiplied 2 there, so I'm going to divide both sides by 2. Now, my absolute value symbol is isolated, and this turns into 6. 12 divided by 2 is 6. Now I can write two equations and solve. All I have to do is say, well, 2x is either 6, or 2x is negative 6. All right, because if I plug a negative 6 in here, if I replace this 2x with a negative 6, the absolute value of negative 6 is 6. Okay, so I solve both of those. I think it's pretty easy to see that I have x equals 3 as a solution, or x equals negative 3 as a solution. And you would see it written like this on today's worksheet. Doesn't matter which one comes first. You could have the 3 first and the negative 3 second. Okay? Alrighty, so we isolated our absolute value by undoing an added 7 on both sides, subtracting 7 from both sides, rewriting, dividing both sides by 2, rewriting, and then writing our two equations and solving. That gave us two solutions for the absolute value equation. And here is the fourth kind. Solve, always isolate the absolute value expression, then write two equations and solve. Remember, if you take the absolute value of something, like this, the absolute value of x, and say it's going to be negative, that'll never happen. There's no number that you can plug in here for x such that if you take the absolute value of it, you'll get a negative value. It won't happen. So if you run into that, you can stop working right there and just say, well, there's no solution. Here's what it might look like. This one is going to, I think that this one is going to, oops, this one's going to give us that situation. Oops, having trouble here. There we go. First thing I want to do is isolate this. We always isolate the absolute value symbol. So I'm going to subtract 5 from both sides, then divide it by -4. Subtracting 5, rewriting. Don't get in a hurry. What is 53 minus 8? Minus 5, 48. And now I'm going to divide by -4. This will cancel this. Divide by -4 here. And I wind up with the absolute value of 4 plus 8n is equal to, what is that, -12? 48 divided by 4 is 12. 48 divided by -4, that's supposed to be a -4, is -12. And I look at this and it says the absolute value of this is -12. I can stop right there. As soon as I see the absolute value is -12, I can say there's no solution. Because there's no value you can plug in here such that when you take the absolute value of it, you'll wind up with a negative value. It just doesn't happen. So there's no solution. Okay. Now, up here on many of our problems, we got negative answers. It's okay to say that there's a negative value you can plug in here and then take the absolute value of it, you'll get a positive value. But if you say that you're going to take the absolute value of something and get a negative value, that'll never happen. The variable itself can be negative. It could be -3, because if I plug in a -3 right here, this will give me -6. The absolute value of -6 is 6. But if I say that the absolute value itself is negative, you can stop, say no solution. Okay? That's a brief introduction to solving absolute value equations. And remember to isolate before you write your 2 equations. Always isolate before you write 2 equations. Okay? Best of luck.